Hey class, so this is going to be a lesson on 3.1 on a type of differentiation called implicit differentiation. We've talked about the notation dy dx before. It means the derivative of y with respect to x. And when we say with respect to x, what that means is that y is a function of x. And so we're looking for how y changes as x changes. Okay, so that's what that's telling us. We're going to first of all look at how we did this problem from Unit 2, and then we're going to show you the new way called implicit differentiation, and hopefully you'll see it's a lot easier. You were asked to find the equation of a line tangent to this curve, which this is a circle, x squared plus y squared equals 169. So that is a circle centered at the origin with radius 13. And the 0.5 negative 12 is right here. And so we're looking for the equation of that tangent line. So the way we went about doing was we solved for y. So we had y squared equals minus x squared plus 169, and y equals plus or minus the square root then of minus x squared plus 169. So the plus or minus is whether we're above the x-axis or below the x-axis. Since the point where I want the tangent line is below the x-axis, that means y needs to be negative. So I took the function, I need to take the function y equals negative x squared plus 169 and take the derivative of that. So that was y prime equals the negative, this bringing down that exponent that is the square root of the inside googly times to the negative 1/2 power times the derivative of the negative x squared plus 169, which would be minus 2x. So the negative 1/2 and the negative 2 cancel, and I have x times minus x squared plus 169 to the negative 1/2. All right, so then I want the I want the slope at the point x equals 5. So let's maybe switch colors here so we can see we're kind of changing here. So y prime at negative 5, not negative 5, sorry, at positive 5. Y prime at 5 is 5 times minus 25 plus 169 to the negative 1/2. All right, 169 minus 25 is 144 to the negative 1/2 means 5 over the square root of 144 means 5/12. So that was the slope of the tangent line. And then we could find, we've got the slope and we have the point 5 negative 12. And so we could get the equation of the tangent line from that. Right now, I'm really interested in getting that slope. All right, so let's look at our alternative method, which we're going to use something called implicit differentiation. So my equation, again, is x squared plus y squared equals 169, and I want dy dx, the derivative, at the point 5 negative 12, okay? So notice the notation that I'm using. I think we've seen this before, that you can draw a line and then put down the point at which you want the derivative. So here's the basic idea behind implicit differentiation. You know how we've kept saying googly, like you're using the chain rule. You have something like if you wanted the derivative of f of 3x plus 1 to the 4th. Oh, sorry, not a good example. Of the function f of x, say, to the 4th power. Okay, we've said the derivative would be, okay, that's 4 times my googly. So this is basically googly to the 4th power. So I use the power rule, bring down the 4, my googly, which in this case is f of x, to the 3rd power, times the derivative of googly, or the derivative of whatever that function is inside. Instead of writing f of x, okay, for some function of x, I'm using y, right? Y is nothing more than a function of x. We're used to that idea. So the derivative of 2x, of x squared, when you're taking the derivative with respect to x, is just 2x. The derivative of y squared, that's like y is a function of x. So that's like something, some function, googly, to the 2nd power. So it'd be 2 times my googly to the 1st power. How am I writing googly? I'm writing y. Times the derivative of y, which I'm going to write as dy dx. That right there is implicit differentiation, essentially. The derivative of 169 is 0. So what I want, of course, remember, is we want the derivative of y with respect to x. Well, here it is. I just have to solve this little equation, and I know what dy dx is. So solving that equation, I'm going to take 2x to the other side. I'm going to divide by 2y. And so that would just give me minus x over y. So one difference is that the derivative can be in terms of y. Up here, our derivative was solely in terms of x. But it's okay, because quite often we know what the y value is. So we're wanting dy dx at the point 5, -12. So plugging 5 in for x and -12 in for y, I'm going to get the opposite of 5 over -12, which is 5/12. And lo and behold, that is the answer we got using the other method. So implicit differentiation, it's called implicit because y is not defined explicitly in terms of x. Y is still a function of x, but it's implicitly defined. Implicit means you don't have y equals. Y just appears somewhere within the equation, and you can work with that. The thing that's nice about this method is that y technically is not a function of x because y equals plus or minus. So for one x, excuse me. So you plug in one x value, you get 2 different y's out. That's not a function. But we do know what the derivative is going to be. So we can get derivatives for functions, for relationships that aren't explicitly defined as functions. All right, and that's why y is involved here. So here's a summary of the process. You will differentiate both sides of the equation with respect to x. Collect the terms with dy dx on one side of the equation, factor out dy dx, solve for dy dx. So basically steps 2 through 4 here is how you solve an equation for a variable. So if you, hopefully, if you get through that first step of finding the first line, taking the derivative, you're going to be good. All right, so let's try to find the derivative of this function right here at 0, -2. All right, so remember we're differentiating with respect to x. So x cubed is just 3x squared. Now, right here, xy, y I'm going to think about as a function of x. So I've got to use the product rule here because it's the minus x times y. So I might do minus, and then I'm going to do brackets because I'm going to have to subtract the whole thing. So it's leave the first function x times the derivative of the second function. Well, I don't know, I don't have y exactly. I just know it's a function of x. So I'm just going to write, hey, the derivative of y is dy dx. All right, plus the derivative of x is 1. And then I leave the other function y. All right, plus. So now I'm ready to take the derivative of the y squared. All right. So basically that's like goobly squared. So you do 2 times your goobly to the first power. My goobly is y, times the derivative of my goobly. So that would be y prime, except I want to write dy dx is the notation I'm using. You can use y prime. Right now I'm using dy dx. And the derivative of the 4 is 0. All right. After that step, basically I just need to solve for dy dx. So I have 3x squared minus x dy dx minus y, so I'm distributing the negative, plus this was 2y dy dx equals 0. So here's one term, here's another term that involved dy dx, and I'm just going to solve for that. So this is basically just like, you know, algebra 1, solving it for the variable. So I'm going to put the 2 terms with dy dx on this side. All right, so there was a minus x here and a 2y there, so that's there. And then the other terms, I'm going to take to the other side. So minus 3x squared plus y. Okay, so this term and this term, I just take to the other side. Okay, so dy dx equals minus 3x squared plus y divided by minus x plus 2y. And that's my derivative. Now it asked for the derivative at 0, -2. So then I can go, okay, dy dx at 0, -2 is, and I'm just going to plug into here, x is 0 and y is -2. So I would have 0 minus 2 over 0 minus 4. So that would be 1/2, it looks like. All right. Another example. Again, I'm going to start off by taking the derivative, keeping in mind every time I see y, I could sort of say in my head goobly. Okay. So this time I have x squared times y. That means product rule. So if I take the derivative of the x squared, leave the y, plus leave the x squared, take the derivative of y. Well, the derivative of y is just dy dx. All right. So that's the derivative of the first term minus the derivative of xy squared. Product rule again. I take the derivative of x as 1, leave the y squared, plus leave the x, derivative of y squared. Again, the y, you think goobly. So goobly squared, the derivative is 2 times the goobly to the first power times the derivative of the goobly. All right, and notice I did minus and then brackets because it's minus that whole sum that I get from doing the product rule. Derivative of -6 is 0. Now I could solve for dy dx. If you're asked for the derivative dy dx, you should solve. However, here's a little hint. If what you're really after is the derivative at a certain point, you can plug in right now 2 for x and -1 for y in this entire thing. So I'm going to do that. So x is 2, so I'll have 2 times 2, y is -1, 2 squared is 4 times dy dx minus y is -1, y squared, so this would just be 1, x is 2, y is -1, and dy dx is what I'm looking for. Okay, so this gives me -4 plus 4 dy dx minus, let's see, so this would be -4 plus 1, so that'd be -3. Oh, can't add those together. It's 1 minus 4 dy dx. Okay, so the -4 and the -1 makes -5, and I'm going to take that to the other side. And here I've got minus a negative, so that's a positive 4 dy dx plus this 4 dy dx makes 8 dy dx. And so dy dx is dividing by 8, 5/8. All right. Hopefully I didn't make a mistake. Okay. Oh, I did ask for the equation. So let's do the equation of the tangent line. So I have the slope is 5/8 and the point is 2, -1. So remember, most of you, I think, are using this. So some of you are still using the y equals mx plus b. You can. There's just a greater chance of making an error because all you have to do here is plug in y minus -1, slope is 5/8, x minus 2. You don't have to simplify. You can stop right there. Okay. So it's really quick and less calculation than if you're trying to do the y equals mx plus b as a way to solve. All right. So another example, we're going to find dy dx using implicit differentiation. This time you're not being asked for the derivative at a certain point. So we can just go ahead and look for dy dx. Again, when you see x cubed, think goobly to the third power. How would I take the derivative of goobly to the third power? I would do 3 times goobly to the second power. X is not a function of x is the variable we're taking the derivative with respect to. So its derivative is just 3x squared, sorry. All right, y to the third power, we think goobly to the third power. And how do you take the derivative of something to the third power? It's 3 to that goobly squared. The goobly is just y times the derivative of my goobly, so times dy dx. Derivative of 1 is 0. All I have to do is solve this for dy dx. So 3y squared, bring over the 3x squared, divide by 3y squared, simplify just a little bit, the 3's cancel, I have minus x squared over y squared. Okay, sine of y equals x. Notice if you were to solve for y here, you would be using arc sine. If you guys remember that. And at least right now, we don't even know how to take that derivative. So we're certainly going to we need to use implicit differentiation here because we can't really, at this point, solve for y and know how to do that. So sine of y is like sine of goobly. Derivative of sine is cosine of my goobly times the derivative of my goobly, so times dy dx, and equals the derivative of x is just 1. So dy dx equals 1 over cosine of y, which would be the secant of y. And that's it. That's your answer. So implicit differentiation can be pretty quick. All right, again, it would be difficult to solve this equation for y. So we really need to use this implicit differentiation. All right, so it's cosine of goobly. The derivative of that is minus sine of goobly times the derivative of goobly. The derivative of 1 plus y is just dy dx. Equals, all right, now I need to take the derivative of sine of x. Oh, well, that's just cosine x, I know that. And the derivative of 5 is 0. So dy dx equals cosine of x divided by the sine of 1 plus y. All right. All right, so sometimes you're asked to find a second derivative, okay? Now, it usually is specified that they want it in terms of y and the first derivative, and I'll show you how we're going to do that. Again, very difficult to solve this for y, so we're going to start off by doing our implicit differentiation, find y prime first. So derivative of 4x to the fourth is 4x cubed. Goobly to the fourth would be 4 times my goobly to the third times the derivative of my goobly. And you can just write y prime. And since this problem is asking for y double prime, I'm just going to use that notation. Derivative of 16 is 0. Okay, so I need to solve for y prime. So 4y cubed times y prime equals minus 4x cubed. So y prime, the 4's are going to cancel, minus x cubed over y cubed. So there's y prime. Now, since I have y prime, to find the second derivative, I can just differentiate normally. Okay, I don't have to use implicit differentiation on this because I have it solved explicitly for y prime, basically. Well, I'm sorry, I take that back. I guess I am because I still have a y over here. So I am going to have to think about it as implicit differentiation. Okay, so y double prime equals, I've got to use quotient rule, low d high minus high d low. So y cubed, keep in mind, it's like goobly cubed. So the derivative of that is 3y squared times the derivative of goobly, so times y prime, all over the square of what's below. So that would be y to the 6th power. All right, so right now we have y double prime in terms of y and the first derivative. So that's kind of a lot. It's in terms of x and y prime. That's a lot. We'd like to get it down to just x and y. Well, I know what y prime is. It's right here. Right? Y prime is right here. I can substitute in what y prime is equal to. And then I only have the variables will be x and y. All right, so y double prime equals minus 3 x squared y cubed, doing a little simplification, plus 3x cubed y squared times that y prime all over y to the 6th. And I should do some simplification here. Thinking about this term divided by y to the 6th, the y to the 3rd, y to the 6th would reduce down to y to the 3rd in the denominator. So I'd have minus 3x squared over y cubed. Okay, now I'm looking at all of this. Okay, so plus 3x to the 6th and a negative, because I had a negative in front of that x cubed. The y squared over y cubed would leave me with 1y in the denominator. I still need to remember it was all of this. This is equal to this, and I still have to divide by y to the 6th. So let's finish this up. The first term I can't do much else with. The second term I can multiply y times y to the 6th. So I have minus 3x to the 6th over y to the 7th. And that's my derivative, my second derivative, excuse me. All right, so when you're asked for the second derivative, you find the first derivative, solve for dy dx, then take the derivative of that, which is what we got all this from. You end up with a y prime. You replace y prime with what it's equal to, okay? so that in your final answer, you have just x and y. You don't have y prime. All right, let's do an example, another example of a problem, something we could do with this. We are being asked to find the where this graph has a vertical or horizontal tangent line. You know what? Let's go to, sorry, hang on just a second. Let's go to Desmos and graph this so that we can get a sense of what this looks like. All right, the function is 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. Ah, that's an ellipse. Okay, so there's going to be two places where I have horizontal tangent lines, right up here at 1, 0, and at -4, at 1, -4. And I will have vertical tangent lines right here at 2, -2, and at 0, -2. So that's what I should be ending up with. Let's see if we can do it. All right, let's go back to my sharing my iPad. Give me just a second here, folks. Sorry. Okay, so obviously I don't want to solve this thing for y. I've got a y squared and a y, and it would be a mess. So implicit differentiation, we love you. All right, so derivative of 4x squared is 8x. Derivative of y squared, that's like goobly to the second. So 2 times my goobly times my derivative of goobly. Derivative of 8x is -8. Derivative of 4y would just be 4 times the derivative of y. Derivative of 4 is 0. Derivative of 0 is 0. Okay. So I want vertical and horizontal tangent lines. I think I should go ahead and solve for y prime. That's going to make this easier. So here's my two terms with a y prime. So 2y plus 4 times y prime. And then here's my two terms that I don't have y prime. I can take them to the other side. So 8 minus 8x, it looks like. So y prime is 8 minus 8x over 2y plus 4. And I can divide everything by 2. So 4 minus 4x over y plus 2. Okay. I have to admit, I just kind of like to make sure that I'm on the right track so that I don't mess it up. Yes, I am. That's the right. I got the right answer. Okay. So how do I find a vertical tangent line? Well, vertical lines have no slope. Okay. So that the only way I'm going to get no slope is if my denominator is 0. So we set the denominator equal to 0. The denominator is y plus 2. So obviously y equals -2. But I want the x coordinate that goes with that. Okay. So I plug y equals -2 into the equation that relates x and y, the original equation of the graph. Because all I'm wanting at this point is, and I know on an ellipse, there's going to be two places where y is -2 because it's an ellipse. So I'm going to plug that in there. So I've got 4x squared plus -2 squared, plugging into here would be 4 minus 8x plus 4 times -2 would be -8 plus 4 equals 0. So that's a simple equation to solve for x, hopefully. So I've got 4 plus 4 and -8. That's all just 0. So I have 4x squared minus 8x equals 0. Factor out of 4x, I have x minus 2, x equals 0, or x equals 2. So that gives me 2 points when x can be 2 and y -2, or x can be 0 and y -2. So those are the 2 points where there are vertical tangent lines. Okay. And then we need the horizontal tangent lines. Okay. Horizontal tangent lines have slope 0. So set y prime equal to 0. Well, y prime is a fraction. The only way it's going to be 0 is if the numerator is 0. So 4 minus 4x has to equal 0. So 4 equals 4x, x equals 1. All right, and just like over here where once I found what y was, I had to figure out the x's that go with that. Since I know x is 1, I need to figure out the y's that go with that. So I will plug x equals 1 into that equation, to the original equation. So let's see if I can get it all on the page here so I can see it. All right, so that would give me 4 times 1 plus y squared minus 8 times 1 plus 4 times y plus 4 equals 0. So notice the 4 plus 4, the negative 8 all cancel out. I'm just left with y squared plus 4y equals 0. Factor out a y plus 4 equals 0. Y equals 0 or y equals negative 4. So those are the two values that go with 1. So 1, 0 and 1, negative 4 are where there are horizontal tangent lines. Okay. Thanks for listening, guys. Do the 3.1 homework. Let me know if you have questions.